this point in our story, it's necessary to understand the effort behind the collecting of measurement data. For what good is a test unless we can learn, can profit from the experience? Highly specialized, sometimes costly instruments help scientists bring home this vital data. An outstanding example of such specialization is the use of a helium atmosphere box by the Naval Research Laboratory. The plywood tube, looking like a train of boxcars, runs from the shot island across the causeways to a detection station on Bogan, a distance of nearly 2 miles. Inside the box, the helium is contained in 200-foot polyethylene balloons, some 45 balloons being required to fill the plywood tube. The detailed progress of the Mike reaction will be studied by utilizing this device. The measurement starts in the Mike cab with a collimating shield, a large concrete block designed to stop all radiation which might confuse the issue. The setup is a lot like having peepholes in a fence. DT neutrons from the Mike reaction will pass through holes in the concrete wall and react on iron converters to produce gamma rays. These gammas will then be collimated through the long helium tube or column to the detectors. Helium is being used for a good reason. Gammas traveling through normal air will have a difficult time of it because of the relatively large size of an air molecule. Now the helium molecule is much smaller, and the gammas will have a relatively free path in which to travel, and hence will be 1,000 times more intense at the detectors. This experiment is one example of the kind of unique instrumentation needed for learning the secrets of weapon behavior. In addition to the diagnostic kind of measurement, many studies are being run on the effects expected from a high-order detonation. These projects are being conducted jointly by the AEC and the Department of Defense. As always, there are many questions to be answered. Classical routine questions and special pertinent questions pertaining to the hydrogen device Mike. For example, what will be the blast pressure on and near the ground? Many instruments, like the Rialco gauge, will measure overpressures at ground level and from 15-foot towers. What will be the blast effects at low altitudes, say up to 300 feet? Mortar shells will label the air with smoke puffs for photographic study of their action. And what about high altitudes? For this, anti-aircraft guns are being used. The bursting shells from these guns will label the air with smoke up to 26,000 feet for a free air pressure measurement. Not only will the ground and air be measured for pressures, but also the water surrounding 0 point. For instance, what will be the motion of the waterways in the lagoon? To get such data, photography will study the movement of these floating targets. And then what about the underwater shock wave in deep water and its effect on underwater ordnance and vessels? This interesting pressure versus time measurement will be obtained by reading pressure gauges which have been attached to the mooring cables of can buoys. Then there are the questions concerning the direction and magnitude of the wind accompanying the shock wave and the afterwind which follows it. The story of heat or thermal radiation needs continued study. The ever-interesting history of neutrons will be recorded. What amounts of external neutrons are present? And what is their energy distribution? Because of the expected size of the shot, the fallout problem is being extensively analyzed. There are questions on the size of the particles, when they got there, and how hot they are. Rafts placed out in the lagoon constitute one method of collecting this information. For a more realistic kind of evidence, a B-36 and a B-47 will be in the air to find out the effect of blast and heat on delivery aircraft. These heavily instrumented aircraft should bring back a record which will indicate whether delivery techniques need to be changed for very high-yield weapons. Well, you could go on and on about the experimental projects being run on this operation, but in so doing, you run up against the same old problem. Each project is so specialized that it becomes a study in itself. So we have given but an impression of the 60-odd experimental projects being run on Ivy.
Latest word from the control room is that everything's going according to Hoyle.
Is the hydrogen level holding?
Right, just as calculated.
She's holding. She's holding. Isn't that what you're thinking, Crone? It wasn't too long ago, 50 days to be exact, when you stood on the beach and watched Mike arrive in crates. A thing then dismembered, a sleeping giant, a robot taken apart for the long trip across 4,500 miles of lonely ocean. And then it was home. Here in a building more like a laboratory than a workshop, it would be assembled for the last time. As you looked at the mass of crates and boxes, you couldn't help but wonder, could you, whether there would be time to make order out of this chaos. When you remember back, items moved into place like notations in a diary. Yes, for you, Crone, the days of preparation fly in kaleidoscopic fashion across your mind. Days now in the past, just as Mike itself will soon be in the past.
3, 2, 1, hack. H minus 5 minutes. H minus 5 minutes. The shock wave will not arrive for several minutes after zero time. Keep firm footing until after the wave passes.
Our latest obtained as we win sounding.
You've been here before, flag plot.
Shows distinctly.
That's General Clarkson, the task force commander, and General Walk, chief of staff. The scientific deputy, Dr. Graves, you've already met. Captain Paul is deputy for naval operations, and General Wise, deputy for the Air Force. As you've gathered, a weather briefing is taking place. I should say another weather briefing. You've probably heard many times before how important the weather picture is in an atomic test operation. Weather can make or break a test shot. That's why you want to know up to the last moment just how you stand with the elements. The problem this time is especially acute because this entire area of the Pacific is subject to radiological fallout. And this area is inhabited by some 20,000 people. Plus, of course, the ships of this task force. That's why the RadSafe officer works hand in glove with the weather officer. Oh, by the way, to help you understand this problem, these weathermen are covering an area larger than the United States with 10 weather aircraft and 11 fixed weather stations. To put it mildly, that's quite a territory to cover. Let's listen in, shall we?
This is a plot of the latest winds received from Enewetak, showing that in the lower levels to 20,000 feet, we have a typical trade situation, followed by southerlies aloft, by westerlies above that, which extend clear up to 85,000 feet. This is just about as good as we can expect. This picture, in addition to the total weather consideration, indicates that all of the weather factors are favorable for our scheduled event. That's all I have, sir.
Any chance of showers?
Not within the next 48 hours over the entire Marshalls.
How about cloud cover?
A few cumulus move in, but if we go off on schedule, nothing to bother the operation.
Are you satisfied from the radiological standpoint, Commander Manor?
Yes, sir. The situation is ideal since the entire fallout pattern is to the north of the inhabited islands.
Thank you, Joan.
The time is now H minus 2 minutes.
Okay, I'll check with staff.
Minus 2 minutes.
One quick question, Dr. Graves.
Well, it'll have to be quick. We haven't much time.
I see. How soon after the shot will you know how big Mike went at?
We will get rough estimates, like from the bang meter, a few minutes after the shot. See you later.
Right.
Why, sir?
You have a grandstand seat here to one of the most momentous events in the history of science. In less than a minute, you will see the most powerful explosion ever witnessed by human eyes. The blast will come out of the horizon just about there. And this is the significance of the moment. This is the first full-scale test of a hydrogen device. If the reaction goes, we're in the thermonuclear era. For the sake of all of us, and for the sake of our country, I know that you join me in wishing this expedition well.
It is now 30 seconds to zero time. Put on goggles or turn away. Do not remove goggles or face burst until 10 seconds after the first light.
Minus 15 seconds. Minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, T0.
The cloud is still rising. 70,000 feet now, if the last estimate I heard is true. And up there at this moment, at about 45,000, are the sampler aircraft. F-84Gs, manned jet fighters, are being used exclusively on this operation. Experience has proven that manned aircraft are just as efficient and much less costly to put in the air than are drones for sample collecting. Jets were selected because they can operate at high altitude. Since the force of Mike shot has pushed the cloud up to around 100,000 feet, it is necessary to get aircraft up high enough to get reliable samples. Even at that, they're scraping the bottom of the barrel, so to speak. Some 14 F-84Gs are being used at staggered intervals to get a good cross-section of the cloud at different times. The jets, which are based on Kwajalein, also have the speed necessary to make them good sample-collecting machines. For the relatively short length of time the pilot is in the area, he gets a good sample per rate of contamination. One of the disadvantages of using jet fighters is their range. To handle this problem, KB-29 tankers, flying gas trucks, are in the air to refuel the jets on the way back from their sampling mission. The jets are also short on over-water navigation aids.
Charlie 1, this is Red Leader. Request steer to Dog 2. Over.
Red Leader, this is Charlie 1, steer 310.
A B-29 control aircraft gives the samplers headings and rendezvous points and generally orientates them in this remote region of the Pacific. The control aircraft is fully equipped with radar and communications. and in essence performs all the functions normally thought of as being controlled from a ground air operations center. A B-36 is also in the air as another kind of control ship, like a football coach running the game from the sidelines. A scientific controller watches the formation of the cloud and directs the samplers in for their runs. When a sampler aircraft has obtained its allotment of contamination, it has done its job and returns to Quaj. That's part of the air story going on right now. Other aircraft are getting ready to track the cloud and also to collect samples for long-range detection studies. Dr. Graves?
Well?
Yeah. Do you know the yield on Mike yet?
I'm just going to find out now. Come along.
The bang meter records are in. The dots indicate the time in milliseconds.
Well, what's the verdict, Herb?
About 12 megatons, Al.
Nice going.
What this tremendous blast did to the atoll, nobody knows. Re-entry parties are leaving the Rendova now by helicopter. The Navy Task Group, commanded by Rear Admiral Wilkins, has the problem of providing the means to re-enter shortly after the blast to get exposed film, samples, and other scientific data. Since no land mass is available, the problem is complicated. Re-entry must be from a ship. Further, fallout will be very high, starting at about N plus 1 hour. Helicopters must get in quickly and get out again before that hour is up. One survey group is leaving here from the Estes. I can't go along, but you can, and see for yourselves through the eyes of the camera what has happened back on the atoll.
Nothing there but water, and what appears to be a deep crater. Water dark blue in color.
Well, the Mike phase of Operation Ivy is about over. The next and final phase, King Shot, will be an airdrop of a large yield fission weapon. And for this, I'll leave you to the air.
Destiny Control, leveling out at 8,500 feet for IFI.
The top aircraft for King, this B-36, is on its way to the target point. Steadily, monotonously, it wings its way from Kwajalein to a point in the sky over Enewetak Atoll. For the first time since Operation Crossroads back in '46, an atomic weapon will be airdropped on our Pacific proving ground.
AC to pilot, will you take over for a while?
And you, Colonel, what are you thinking as you relax for a moment from the controls of this strategic bomber? This bomber whose cockpit now resembles a closed room, curtained off from possible dangerous effects of heat and light. Are you thinking of the mission, or of Kwajalein, or perhaps of home? Home, you certainly can't call Kwajalein home, even though it now looks like an extension of the Carswell Air Force Base. Talk about crowded. In addition to the normal complement of the island, Kwaj has been the major base for our Air Force ever since this operation began. This small atoll island is the jumping-off spot for the Air Group, commanded by Brigadier General F.E. Glansberg. Operation Ivy isn't like Greenhouse, when Enewetak Island was used in addition to Quaj. In a sense, Wetak is still used, but just for L-13s and copters, aircraft easy to evacuate. Look at this lineup on the Quaj airstrip. Samplers, tankers, weather ships, photo aircraft, trackers, control planes, drop aircraft. Looks like it's harder to find a parking space here than in downtown Fort Worth on Dollar Day. But now Quaj is behind you, Colonel, and you're on your way to doing something big. Big, like you were told back at the briefing.
So much for the operational plan. Perhaps some of you are wondering about the idea behind the dropping of such a high-yield weapon. General Glansberg has a few words he'd like to say to you on this subject.
The Department of Defense has indicated that certain targets may require a bomb of such yield as the one you will be carrying tomorrow. And it's your job to put it down the pickle barrel so that they can do a decent job of proof testing it. One other thing, there's been a lot of talk about why we selected the B-36 to do this job. The reason the B-36 was selected is because it has metal control surfaces. There is still some argument as to what will happen from thermal radiation on fabric surfaces. So now you know you will have a heat problem.
AC to Weaponeer. How's the IFI coming along?
Weaponeer to aircraft commander, IFI proceeding satisfactorily.
As you carefully check off each item of the in-flight insertion, Captain, you can tell that the preparation of the King weapon is moving along on schedule. But not too long ago, this weapon did not exist. To get King ready for Ivy, the weapon was being worked on in the States almost up to the last minute. So the weapon, minus the nuclear component, was ferried out to Quaj by a C-124. In the meantime, after the Mike shot, the Curtis sailed to Kwajalein. Assembly people from this ship work in conjunction with Sandia in preparing King for the airdrop. Following normal safety measures, the nuclear components of King arrived from the States in a separate aircraft. And now this super-fission weapon, completed, ready, is taken from its shipborne assembly shop and moved under the cavernous belly of the waiting B-36. As the B-36 moves on its way to the target, the weather situation suddenly changes and becomes unsuitable for the test. And this means that the finely coordinated effort has to be canceled and the drop plane recalled to Quaj. For 72 hours, the King phase of Operation Ivy waits on weather. Men and machines who have been geared for the mission have to start all over again. Finally, shortly after dawn on November 16th, the go-ahead is given. This time there will be no turning back. This time, King is on its way to the proof test for which it was created.
Weaponeer to aircraft commander, IFI completed.
AC to engineer. Set climb power.
And so the King bomber climbs into the thin air of the stratosphere and levels off at 40,000 feet, its bombing altitude. Here the radar operator, or bombardier if you will, guides the aircraft to that four-dimensional yet imaginary spot so necessary for pinpoint accuracy.
Radar to AC, approaching target area.
The radar operator positions the aircraft in space with a movement of his hand, continuously running a cross-check between the radar bomb sight and the visual system, back and forth, first peering into one scope and then into the other. During these critical moments, the vital facts flit across his mind. Ground zero, 1,900 feet to the north of Runnet on the Coral Shelf. Height of burst, 1,500 feet. Allowable margin of error from ground zero, less than 500 feet. Zero. In the 56 seconds it takes the bomb to fall, the men of Operation Ivy wait on Parry and Enewetak Islands. Unlike the Mike phase of the operation, the King phase will be observed from land. The bomb is now at 8,500 feet. at 6,500 feet, at 4,500 feet, at 2,500 feet, approaching 1,500 feet. Watch the air overrun it. What about Mike? Let us now go back and examine the evidence and point up the statistical highlights of that device. Remember those final last seconds?
5, 4, 3, 2, 1, T0.
This is the largest fireball ever produced. At its maximum, it measures about 3 1/4 miles in diameter. Compared to the skyline of New York, this means that with the Empire State Building as 0 point, the Mike fireball would extend downtown to Washington Square and uptown to Central Park. In other words, the fireball alone would engulf about 1/4 of the island of Manhattan. The tremendous upsurge of air from the detonation rapidly pushes up the Mike cloud. Again, nothing of this height and width has ever before been witnessed. If the picture is stopped at this point in the cloud's growth, the height of the cloud is approximately 40,000 feet. This means that 32 Empire State Buildings at 1,250 feet per building could be piled one on top of the other before they would attain the cloud's height at this time, roughly 2 minutes after 0. Some 10 minutes later, the cloud approaches its maximum. At this time, the mushroom portion of the cloud has pushed up to around 10 miles and spreads out along the base of the stratosphere to a width of about 100 miles, while the stem itself is pushed upward deep into the stratosphere to a height of about 25 miles. Later figures put the Mike yield at around 10 megatons, or 10,000 kilotons. This means there was more energy released in this one shot, roughly 10 times more than in all previous atomic blasts combined, including probably those of Russian origin. Or to put it another way, 4 times more power in this one shot than from all the high explosives dropped by the entire Anglo-American Air Force on Germany and the occupied countries during the last war. The results of this tremendous power can be shown at the atoll. Here is an aerial photo of the test area of the atoll before the blast. And here is the same area after the blast, showing the crater caused by Mike. The outlined island in the center is former Illugelab, the 0 island. Sections of the islands on either side have been chopped off. The crater is roughly a mile in diameter. When it is illustrated that some 14 Pentagon buildings could be comfortably accommodated in this hole, the size of the Mike crater becomes more real. In profile, the crater gradually slopes down to a maximum depth of some 175 feet, or equivalent to the height of a 17-story building. The lateral destructive effects are the greatest yet observed from a single explosive device. Without getting into the areas of target evaluation or secondary effects, it can be safely assumed that there was complete annihilation within a radius of 3 miles, or out to and including all of Enjabie, that there was severe to moderate damage out to 7 miles or down to Rougeoro, and that light damage extended as far as 10 miles or down to Running. Relating this area of damage to a city like Washington, D.C. would present a picture something like this. With the capital as 0 point, there would be complete annihilation west to Arlington Cemetery, east to the Anacostia River, north to the Soldiers' Home, and south to Bowling Field. Complete annihilation, and that is mentioning merely the primary damage.
Well, it's all over. Mike shot and King shot are history, and we're back here at Perry Island winding things up. It's been a pleasure to help bring you the story of Operation Island, the work of Task Force 132. Now that it's all over, I have sort of an inadequate feeling. There's so much more that could have been said. But then in a presentation of this kind, one can only hope to give the broad brushstroke. And the men who told you the story, we're only able to pick out a few of the many. You get a feeling, even now, that nothing is really over. That this is a breathing spell, like a lull in battle before the next attack. The feeling is on this island, with the men here.
Yes, the coral sands of Enewetak Atoll have viewed events in the fall of 1952, which less than a year and a half before would have been colossal accomplishments. Today, they are calmly accepted. This is characteristic of the progress being made in the weapons development program. What is new today is old hat tomorrow. And of the day after tomorrow, who knows what these Pacific sands may see?